All right, so worksheet 2 and 3, we need to finish 2 or we need to finish 1? Okay, we're just going to look at 2B today, rate of change. I feel like we do need to go back and do some slope or some restrictions on domain stuff. So I'll hit that. And I promise to do questions on homework today. Which worksheet page is that? Okay. So did we do 12 yesterday? Okay, so 13. Hang on, got my cursor issues going here. I dropped my little tablet here yesterday, so that wasn't a cool moment either. So I hope it's not broken. Seems okay. All right. So the issue, yes, please, thank you. The issue with this one is really only the domain. I am not going to ask you for the range on a rational function like this, okay? And the reason is when you go to graph it, we will eventually do days on rational functions. And there will be an asymptote here that's horizontal and it doesn't go below, and then this has a maximum, so there's a place where the y values don't exist here. So it's the range is not negative infinity to infinity. It would have a break in here where there's no y values. I'm not worried about that. I really want you to be able to do the domain restriction on this. Okay, the big deal for domain, remember, is there an x in the denominator or is there an x under a radical? Otherwise, the domain's all real numbers, okay? So don't let it freak you out. This has x's in the denominators, so then the issue is you have to say, well, the denominator can never equal 0. What values would make this equal 0? Everybody good? So what we have to say is the domain is all real numbers except x cannot equal 3 or 5. Now, in interval notation, that's kind of a pain in the neck. You have to say everything up to 3, not including 3, then everything between 3 and 5, not including 5, and everything from 5 to infinity. The graph over here has 2 vertical asymptotes, one at 3 and one at 5. But it took me a lot to get a window that looked like that in. I'm just telling you, looking at this graph and isn't necessarily going to be a fun time trying to figure out where those places are. You just need to know, set the denominator equal to 0 factor, okay? All right. Let's try these 3 extra practice ones down here so we feel a little bit better about domain. Does that sound good? Here, I put them on this page. Okay, so this domain would be all real numbers except what would make the denominator 0. You don't have to write them down if you don't want. Just help me out. What would happen here? You are good. Factors like that. So x cannot equal -3 or -4. Do I need to write out the interval notation again, or you're good? You okay on that part? All right, what about this disaster? Do you remember? Under a radical, you can only square root what kind of numbers and get real answers? Positive numbers. Almost. Can also square root 0 and get 0. Okay? So the rule for a radical is what's ever underneath here has to be greater than or equal to 0. This is a mess because if I factor this, or if I graph this, or if I move the 4 over and do square roots, I'd have to do a plus or minus. There's two answers here, right? This one would be helpful to graph, probably. If you were looking at this, it says we have A equals 2 or negative 2. And we're trying to figure out whether it's values outside of that or inside of those, or where does it actually work. What happens if I put a 1 in here, guys? 1 squared minus 4, is that going to be okay? No. What if I actually put a 2 in there? Would that work? What if I put a negative 2 in there? Yes. What if I put a 5 in there? Yes. I think the graph probably looks like this. Anybody type it in? Okay. So what values are okay for the domain of this? Negative infinity to what? Negative 2 with a square bracket and 2 to infinity. That's tricky. Okay, that is definitely tricky. I would have left the squared off if I was going to ask you that question, probably. What about the range? Can you tell me the range of that just to practice? Because we're doing more range today. If this is the graph, range, remember, is bottom to top. What's happening from the bottom to the top? When do you start seeing values? Yes, at the y value of 0 and up, because this is going up. Remember that? Okay. What's different on 5C? Anybody know what's different? A radical and the denominator, okay? Whatever's under the radical normally has to be greater than or equal to 0. Because it's in the denominator, it has to be what? Greater than 0. Can't equal 0. Do you understand what I'm saying? You can't divide by 0. All right, so if we solve this, we get what? X is greater than negative 3. That's it. So the domain is negative 3 to infinity. Okay, don't overthink these. This one was icky. But if I had dumped this squared off there, all you would have had to do is say a minus 4 has to be greater than or equal to 0. A is greater than or equal to 4. 4 to infinity. Okay, so what are the two things to worry about again? Domain is all real numbers unless there is x in the denominator, in which case you have to figure out what values would make that denominator 0 and restrict those, throw them away. What's the other thing to look for? Radical, like a square root or a fourth root. Okay, if it happened to be a cubed root, which I'm not going to ask you at this point, you can take a cube root of a negative number. You remember this, yes? Like negative 2 times negative 2 times negative 2 is negative 8, so you could take a cube root of negative 8. So, yeah, sideways cube root graphs look like this. They have domain and range, or domain of all real numbers. But, all right, we good on that? Finishing up domain and range a little bit? All right, then we're going to talk about worksheet. Oh, I had a warm-up. I must skip my warm-up. I am recording. We're good. I'll do this warm-up. Just find the slope between these 2 points, because this regard is in regards to the lesson today. How do you find slope between these? So what do I do? 395 minus 380 over 15 minus 12 is 15 over 3 is 5. Okay, you actually just found the rate of change between a linear equation and between those 2 points in a linear equation. Okay, that's the lesson today. I can calculate the rate of change between two values of a function. So this crazy business Says the average rate of change between f of x between a and b is f of b minus f of a over b minus a. It's a slope, guys. Okay? And it doesn't have to be a linear function to find the rate of change. It is average rate of change. So if I have a graph like this, the average rate of change as I pick these 2 points is much different than the average rate of change between those 2 points, because all you're calculating is the slope here and the slope here. Do you see that this rate of change is greater than this rate of change? Okay, that's calculus. There's a whole bunch of that in calculus. All we're going to do is the average rate of change, which means we're going to calculate the slope. Even though a curve doesn't have a slope, it has a average rate of change between 2 chosen points. Okay, this is a line. I could tell you the average rate of change right now, but we're going to do what it says. We're going to find x equals 3. So can you find f of 3? What do you get? 3 times 3 minus 4 would be 5. So we put in a 3, got out a 5. We're going to think of it that way. And then it says find f of 8. 3 times 8 is 24, minus 4 is 20. Did I do that right? So we put in an 8, got out a 20. So to calculate average rate of change, you simply do change in y over change in x between these 2 points. So 20 minus 5 over 8 minus 3 is 15 over 5 is 3. Anybody know how I knew ahead of time what was going to be 3? It's a line, right? And the rate of change of a line is constant, and it's always just the slope. Does that make sense? Now, parabola, not the case, right? The rate of change changes as you go around. If you pick 2 points down here, it's a much different rate of change than if you pick 2 points up here, where it's almost vertical. All right, so they say from 2 to 4. So we're going to put in a 2 and figure out what happens, and we're going to put in a 4 and figure out what happens. Is it okay if I don't write f of 2? You get what I'm doing? You're just putting those in? Okay. So 2 squared plus 6 times 2 minus 10. Is it 6? Okay. And then if I put a 4 in, I'd have 4 squared plus 6 times 4 minus 10. 1630. Okay, and then to find the rate of change, I still have to do slope. So 30 minus 6 over 4 minus 2, I'm getting 12. Anybody else getting 12? Or did I just go way too fast? So as long as you can remember what that means, it's not hard, right? The trick is sometimes students goes, I don't remember what I'm supposed to do for average rate of change. Okay, as long as you can remember, it just means find the slope, you're good. All right, so this is a kind of fun question. It says, which is greater, the average rate of change of f of x? Is it greater between 0 and 1 or between 4 and 5? So if I do 0 and 1, and this is my function, remember, or I do between 4 and 5. What happens here? What does 0, if I put it into that function, become? And 1? 1. So what's the rate of change? 1 minus 0 over 1 minus 0 is 1. We all good? If I put a 4 in there and square it, though, I get out 16. If I put a 5 in and square it, I get out 25. So now I have to do this rate of change, which is what? 9? Did I subtract right? I hate subtracting. Okay. So the rate of change is much greater. Does that make sense? If you visualize that parabola, does it make sense that it's going to be much steeper over here than it is right there? Yes? Okay. Which one of these two functions, or these three functions, has an average rate of change, a greatest average rate of change between 2 and 3? Ooh, they're trying to be tricky. Okay, if I put a 2 and a 3 into a line, what will I get out? A y equals x, I get out a 2 and a 3. What if I put a 2 and a 3 into a squared? Get out a 4 and a 9. If I put a 2 and a 3 into the cubed, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27. Okay. Does the change in x change? All of these have a change in x of 1, yes? The change in y, here is 1, here it's 5, and here it's, what, 19? So which one has the greatest average rate of change between those 2 points? The h of x equals x cubed. It has a rate of change of 19. Probably not a question like that on a quiz, at least the first time, but it's not hard, right? All right. This is actually more of what you do in calculus, is you do these little tiny values, okay? Because it has to do with the definition of a limit. So from 1 to 1.1, well, 1 squared is 1. I need, whoops, forgot the 1, okay. 1.1 squared, is it 1.21? Okay. So how much did it change in between there? If I subtract 1.21 minus 1, the y's is 0.21. The denominator, 1.1 minus 1 is 0.1. What is that when I divide it, guys? 0.21 divided by 0.1. 2.1. Okay. Over here, 1 squared is 1. What is 1.01 squared? What is it? 1.02? 1.01 squared is 1.02? Okay. If you subtract to find the slope, 1.02 minus 1 will be 0.02. 1.01 minus 1 will be 0.01. What happens? At 0.1. This will be point. Did I do this right? Okay. So it's 2? Sorry. What happens here? This is still 1, 1. What's 1.001 squared? 1.002, like that. Okay, so if I subtract off the 1s, I'm going to get 0.002 over 0.001, which is 2 again. Was this one round? Were any of those rounded? That. What? What was the second one before we rounded? Okay, if we'd gone a little bit further up here, we would have had 2.01 as our. So what's happening? This value, is this one rounded as well? It's getting closer and closer to 2 is the whole point, okay? You'll do more of those when you get to calculus. If you'd left all the decimal places, it would have got closer and closer to 2. All right. What change does the average rate of change appear to be approaching as it gets closer to 1? The answer is 2. The value you found is the instantaneous rate of change of a function. It has enormous importance in calculus. Okay. So, the average rate of change. So you have already been assigned some problems on page 9 and 10. This is the assignment that goes with, are you on your green sheet? It says to do these problems. So you're supposed to add these to the original assignment on 1.1, and then to do 66 through 72, the evens. That's a whole whopping, what, 66, 68, 70 and 72. And you're to ignore the directions and find the average rate of change between x equals 1 and x equals 3. Okay? If you want more practice on rate of change, there are some assigned. Here's 3 more on page 41. I don't know that you need more practice, but we will hit it again when we get to page 41. If you wanted to do it ahead of time, you could. Any questions? All right. Then I want to talk a little bit about worksheet 3. Did I close that one somehow? Okay, let's talk about domain and range. Can you see this? That's not a very, if I make it. You see the blue parts? Okay, so there's a solid blue dot here, and it's going to the left. Open circle, solid blue dot here, going to the right. And the graph paper is counting by 2s, just to make life more miserable. Okay, this is a horrible question. I would not ask this. But can we figure out the domain? Domain is just left to right, yes? Coming from the left, this has values until it gets to -6. Now, what kind of bracket at -6 and why? Solid dot, so hard bracket, perfect. As we continue over to the right, where's the next time we start to pick up values? Good job, at x equals 0. Soft bracket, because it's an open circle, and that continues until 4, soft bracket. And it picks up again. Then there's an open space here with no x values. It picks up again, I would say, at 7. What kind of bracket? And then it has an arrow off to the right, so we'd go to infinity. We good? All right, what about the range? Start at the bottom. What is the lowest point that has value? -8. Square or parenthesis? Square bracket. Then what? Okay. Does it stop having y values when we get to 6? This one has an arrow, right? So no matter what I do going across, it's always going to have a value somewhere, right? It might have multiple values. So it is just to infinity. Some of you said that right away. I just was ignoring you until I was sure everybody was on board, okay? What? It's going up. Yep, we're good. All right, we're going to talk today a little bit more about domain and range and whether a function is continuous, I think. We are definitely saving this for Monday, okay? So by looking at a graph of a function, you can determine the domain, range, x and y intercepts. The x-intercepts are also called the 0. If you want to calculate them, you put in to, remember to put in x equals 0. So part of this assignment is just looking at the graph. Use the graph to find the domain and range and to approximate the x-intercepts and y-intercepts, then confirm algebraically. All right, so they give us this picture, which is really tiny. I don't know if I can. You guys have this on your graph paper, though? On your paper? Okay. Let me make it a little bit bigger here. I think that'll work. So domain and range first. Can anybody tell me domain and range? Why is the domain -infinity to infinity? It keeps expanding outward. And remember the rules. Here's the equation right up here. Does it have a denominator or a square root? No. All right. The range, that you got to look at the graph and figure out. And unless you're... if you didn't have a graph and you couldn't have a graph and it was a parabola, you'd have to find the vertex, right? Because that's the maximum value. But they've given it to us here. Which value do we want? Yes, because we're looking at the y's. So it would be negative infinity up to 5.0625. Yes? Okay. Estimate the zeros. What's that look like? -3. And what's this look like? 1.4, 1.3, I don't know. If you had to do it exactly, could you type this in your calculator and find those? Okay. Y-intercept, what do you think? You can estimate it. 1, 2, 3, 4.5. Is that right or not? How do you know that's right? Whoops, it would be this way. Yeah, because right here, if you put a 0 in, it would be 4.5. All right. Use the graph to find domain and range, x-intercepts and y-intercepts. What's happening here? Domain and range? Negative infinity to infinity range. Remember I just told you a minute ago that I wouldn't ask you a cube root? But this has a cube root. But can you look at the graph and tell that the y values are going to continue to go up and down? Okay, so it is negative infinity to infinity. What about either x or y-intercept? You guys pick. The y-intercept looks to be at -2, -4, -6, -8. Okay, ordered pair for that. 0, -8. X-intercept appears to be 2. Okay, we could check that by just typing it in, right? 2 minus 1 is 1. The cube root of 1 is 1. 1 times 4 minus 4 is 0. All right, moving on. All right, this is using the graph. This is a different learning target. This is using the graph to find values without the equation, okay? Sometimes they'll give you the equation like here, but I'm not going to necessarily give you equation. I'm just going to give you a picture on a quiz and say find f of -2.5. How do you do that? It's going to be an estimate, obviously. Do you know how to find f of -2.5 if you don't have an equation and you only have a graph? You could, but what if the picture just looks like this and I don't give you any points? Well, you'd have some points. No, it's not really mean. How do you find f of -2.5, guys? It means when x is -2.5 here, what is the y value on the graph? Okay, that's all it wants. So here at -2.5, I get a y value of, is that what it looks like to you? 12. Oh, here, yeah, if you did right there, it does look like 12. If we put it in here, I don't know that it comes out 12. What's -2.5 minus 3 would be -5.5, yes? And then this guy, the 2 and the absolute value would make it positive 5.5 times 2. 11 plus 1 is 12. I think we did well. Okay, estimate 1. What do you want to say there? Looks like 5. If I put it in, 1 minus 3 is -2, become positive 2, times 2 is 4, plus 1 is 5. Beautiful. 7. Yep. 8. All right, so you get what we're doing when we estimate from a graph? All right, domain and range. Who's going to practice these? Easy one. Who's got 3? Left to right? I can't even tell. 2, 4, 6, 8. I think it's -4 because they're counting by 2s. To positive 3 maybe? Range, bottom to top? I think it's -6 to +5 because they're counting. This is -6. This is +6. Yeah. What's even worse, this book sometimes, I don't know if they do on any of these, but they sometimes like go twos on one axis and fours on the other. They'll label it so you can figure it out, but it's a huge pain in the, yeah. I am going to do that to you. I'm not going to say I'll never label by twos, but I wouldn't label one by twos and one by threes or something horrible. Okay, what's happening here? It's going to the left forever, and it stops at 4 for x values, bottom to top. Negative infinity to be, yeah, it is counting by ones there, isn't it? Ah, that is 3. Okay. So, yes, they did it right there. Okay, number 5. Looking at this, can you tell that it's never going to be 0? Because you can't divide by 0. So we need u. Okay, left to right. Are you agreeing with Ariana? Okay. Just because you know she's good or just because you really think that's right? Okay. What about y values, bottom to top? Yeah, same. All right. Did we get to symmetry then? And I'm not doing symmetry today. Okay. So if you wanted to start on 1.2, if you wanted to start on 1.2 tonight or this weekend, don't do 25 on because those are the symmetry questions, okay? So if you want to get some stuff done this weekend so that you're all ready for the homework check, the only ones you could have left Monday night would be those 4, okay? Yes. Yep, questions. I'm going to